Let's solve this quadratic equation by factoring. So you'll notice I already have it in this ax squared plus bx plus c equals 0 form. Since it's solved for 0, my next step is just to factor the ax squared plus bx plus c. So x squared plus 12x plus 35 is what I want to factor. So I want factors of 35, and I want them to add up to 12. So it's not 1 and 35, because that's 36. It's not divisible by 2 or 3 or 4. It's divisible by 5. 5 times 7 is 35. 5 plus 7 is 12. So this thing factors into x plus 5 times x plus 7. That means I can rewrite my equation of x squared plus 12x plus 35 equals 0, as instead x plus 5 times x plus 7 equals 0. Now, from the zero product principle, I know that if two real numbers multiply together to be 0, then one of them is 0, or the other one's 0, or both. I'm left with two nice linear equations to solve. Here, if I subtract 5 from both sides, I get x is equal to negative 5. And over here, if I subtract 7 from both sides, I get x is equal to negative 7. So negative 5 and negative 7 seem to be my solutions here. And let's check. Let's just do a quick kind of mental check. So let's check negative 5. Negative 5 squared is positive 25. Negative 5 times 12 is minus 60 plus 35. That does equal 0. And let's check negative 7. So negative 7 squared is positive 49. Negative 7 times 12 is negative 84. And then plus 35. Does that equal 0? 70, 84, minus 84. Yes, it does. So negative 5 and negative 7 are the two solutions to that equation. All right, let's do another one here. Come on, smartboard. There we go. This time I have y squared equals y plus 6. Now, I need this to be equal to 0. So my first step is get 0 on one side. Okay, to do that, I'm going to take y squared equals y plus 6, and I'm going to move everything to the left-hand side. The real reason I'm doing that is I want my squared term to have a positive coefficient, because when it has a negative coefficient, it's a little harder to factor. So I don't like doing factors that way, because if it's negative 1, I have to do the guess and check method. If it's positive 1, I can just find the factors of the constant that add up to the middle. Okay, so now I have this equivalent equation, y squared minus y minus 6 equals 0. So I want factors of negative 6, and I want them to add up to negative 1. So we can go through them. It's not 1 and negative 6. It's not negative 1 and 6. It is 2 and negative 3, because that adds up to negative 1. So this equation is the same as y plus 2 times y minus 3 equals 0. Okay, now I can use the zero product principle, which gives me y plus 2 equals 0, or y minus 3 equals 0. Solve this equation on the left. I'd subtract 2 from both sides, which gives me that y equals negative 2. To solve this other equation, I'd add 3 to both sides, which gives me y is positive 3. So negative 2 and positive 3 seem to be my solutions. Let's check them back in the original equation. So if y is negative 2 squared is 4, and negative 2 plus 6 is 4, so that checks out. If y is positive 3 squared is 9, and 3 plus 6 is 9. So negative 2 and positive 3 are my solutions, and the solution set for this equation would be the set containing them. Okay, great. How about x squared minus 8x plus 15 equals 0? Again, I'm in the right form. I don't need to set it equal to 0. It already is. I want to factor x squared minus 8x plus 15. So I want factors of 15 that add up to negative 8. Those factors happen to be minus 3 and minus 5, because negative 3 times negative 5 is positive 15, and negative 3 plus negative 5 is negative 8. From the zero product principle, either x minus 3 equals 0 or x minus 5 equals 0. So x is 3 or x is 5. Do a quick check. 3 squared is 9, minus 8 times 3 is 24. 9 minus 24 is negative 15, plus 15 is 0. 5 squared is 25, minus 40 is negative 15, plus 15 is 0. So 3, 5 are my two solutions.